While we have the advantage of component exclusivity with Titan Vs, we want to try and set some records on hardware bot, and that's going to be done by liquid cooling at least one of them. So we have two of these. I bought this one a few days ago. We've been working on it for review. Ours clock's pretty high already, but we need to liquid cool it to get rid of that thermal limit and to reduce power leakage, which will give us more power to use for the core. We are also going to be using this one from channel Bitsby Trippin, who loaned this to us very generously. And we're going to put them in a multi-GPU setup and see what we can do with things like GPU Pi. So this video will be dedicated to liquid cooling our torn down card. We went through a lot of different options for this, and it took us a while to find a good one, but I think we did. So we're going to show you that whole process today. But before we get into that, this coverage is brought to you by iFixit.com and their ProTech Toolkit. iFixit is refreshing their ProTech Toolkit in time for the holidays. You can find a link in the description below to the ProTech Toolkit and other toolkits that iFixit sells. We find the ProTech and Essentials kits to be the most useful for DIY enthusiasts. Okay, so I'm going to show you all the stuff we did, including going through what we did for Vega with some contact paper to make sure what we were doing actually made contact with the GPU and the HBM. The big concern with liquid cooling this type of device is that the HBM, which you can see as these smaller modules flanking the GPU, is very fragile. All the silicon is very fragile, but the HBM especially, it's smaller, it's out of the perimeter, so if you have any kind of like torsional or uneven force on the opposing corners, you could definitely crack the dies, and we don't want to do that because I actually paid for this myself, and it was $3,000. Another option we had was doing you could always do just a better air cooler, but I really want to do liquid because Pascal and Volta behave the same with their clocks, which is basically the cooler it is, the higher the clock. If we can get this below 60C, and I'm confident that we can increase the clock significantly. If we can get it below 50C, we can get it even further, which we might be able to with the help of ambient temperature outside if it's benchmarked outside or something when it's 0C. That would definitely get us there. So let me show you what we looked at. A couple of the options here, and I'll just once again plug our Gamers Nexus mod mat, which is slowly accumulating thermal paste. This is available on store.gamersnexus.net/modmat if you want to check it out. It's grounded, so I'm plugged into a strap, which is plugged into the mat corner, so that grounds the mat, and then that plugs into a common ground point in the wall. So we are pretty safe right now from damaging this card. And when it costs this much, it pays to be paranoid. So options that we looked at. Previously for Vega, we used an Asetek Intel plate like this and then drilled some holes in it. And the problem is Vega is 64 by 64 for the mounting hole distance, the spacing for these mounting holes. So Vega is 64 by 64. This one is about 70 by 70. So if you can see on the calipers there, we're 70 by 70 for this. It is square. And that's a problem. That means we can't use our Vega plate, which sucks because it took a whole lot of work to make. Next thing, I remember these. These are from, I think, Deepcool to adapt one of their coolers to Ryzen. Almost line up with the mounting holes above it. Like one would line up, but not the other. Looked at other plates. We've got stuff like this. That's just entirely too big in any direction, and the holes don't line up with anything. That's a Threadripper plate. So then I remembered this. This is a Be Quiet Silent Loop 280 that they sent us for review previously. It wasn't the best performing on our bench, but it was good enough. And the more important thing than the performance was the mounting plate. So these plates, I think maybe it's Aqua Computer that makes these. AlphaCool, maybe, I don't know. AlphaCool uses the same kit either way, so we could use theirs as well. But these kits just separate, and you can see, if you can see that, those holes are starting to line up. I'm going to have a hard time lining it up for camera, but they are more or less there. We might come in at a slightly off angle. It might not be perfectly 90 degrees. Long term, I wouldn't like that, but if we can get something working, I'd be okay with it. So that kind of lines up. And then this one looks like it lines up almost perfectly, to the point where I was like, okay, so maybe we mount this to the back of the card, run the screw through it that way, put the nut on this side with a washer, and then we'll be done. And you just tape off all the capacitors and components that you might potentially short with these brackets. Well, better option came up, and that is to just straight use the Be Quiet cooler. And we take this, and we'll just mount it right there. So now you're all caught up to where we are. We haven't actually tested this yet. It hasn't been turned on or anything, hasn't even been fully assembled. So we were just figuring out what to even do. And now it's time to do those things, test it. And we're gonna start by, I think I've pretty much figured out the mounting pressure I want, but I'm not positive yet. So I think I want the screws to come through the back side of the card. I want 11.5 millimeters of threads exposed. So there's our 11.5. So we're gonna use that for the, I'm gonna use this gauge down here. The screw bottom will come up to that point, and basically it'll be coming through like this, and then we'll stop once we're at 11.5. This paper, it uses 2 sheets, and they chemically react to each other to create the patterns you're seeing. These are all different Vega cards, and you can actually see on some of them, like this one, you can see the HBM right there and the core, as opposed to one that has an epoxy resin coating like this or this, where it's just the HBM and the core are kind of homogeneous. And nVidia uses that epoxy resin coating, so we're looking for the same reaction. If we do too much pressure, you crack the die or the HBM and you kill a $3,000 card, unless you get exceptionally lucky and only crack the dead HBM or disabled HBM die. Okay, so we need a sheet of this. I think about that size should be enough. That'll be a little bit more than enough. So what we're gonna do, I'm gonna try and slide this in between the plate and the GPU after we start getting it mounted. I'm not gonna use thermal paste right now. I think we want the tubes oriented at the top, be easier to work with. So we're gonna mount like this. And now you might be asking, why don't you leave the base plate on there to cool the VRMs? First of all, they don't really need it. We can just put a fan on there and it will cool just as well, if not better. Secondly, I don't want this plate on here, because if this plate is on here, I have no access to the components. What I want to do is later on, I want to be able to short the shunts. So that's a shunt right there, that 5 milliohm IC, that's a shunt, and we have another one down here, that's a shunt. This one we think goes to the PCIe. You can actually see the traces running down here. So we probably don't need to play with that one. But if we use liquid metal, we can short these two and bypass some of the power or voltage restrictions. And I'm going to talk to Buildzoid about how to do this properly and what kind of results we should expect. But we're going to do that last, after just straight liquid cooling it. So we're removing thermal limits first, then we'll remove some of the power limits by shorting those. Putting the base plate on would make it impossible for me to access those without completely disassembling all the work we're about to do now. And again, these VRMs are plenty strong without the base plate. So we're actually going to remove the pads and not even cool them. And then later, now that we've done all the thermals for this card already, I'll just replace the pads with better ones. Probably like the Thermal Grizzly -8 or whatever they're called pads. So we're going to exploit these as much as we can and push the screw all the way to the inside. Again, it's very easy to cause damage in this process. We would advise that you don't do it, and would also advise that we don't do it. But we make stuff for video, so if it goes horribly wrong, we still get content. And it's kind of been practiced at this point anyway. I've done this with a lot of cards now. Got these on. The next step is going to be figuring out how much to tighten them. So I need to loosen these enough to get that contact paper in there. This has two sides, one's rough and one is shiny. We want rough to contact rough to trigger the reaction. We want white on top of clear. So like this. There will be a bit of a reaction where I'm handling it at the corners, but all right. So we have that in there. Now it's time to start tightening these. There's no time limit on it or anything. I'm going to start by getting the corners opposing to be tight enough that the paper is not going to move. That way I can start handling the card vertically. I know we want to be at least 11.5. That's pretty close. Okay, so that's what it's going to look like when we're done. Now we just need to figure out if we got it tight enough. Unfortunately, that means unscrewing everything, undoing all that work, which wasn't that much, but okay, we need to go tighter on that, I think. So, not great contact. Most of the contact was at the top, which those last couple turns I was going all on the bottom, which means we were kind of imbalanced anyway. Now I'm going to reuse this paper. You should use new stuff, but as long as we see all red at the end, then that's all I'm really going for today. Let's try this again. We'll go to 11.75 this time. I don't think it's perfect, but I'm starting to get uneasy from how much force is being applied. So we're going to see if it looks okay. It does not need to be 100% red. It just needs to be enough that thermal paste will cover the gaps. That's getting actually pretty damn good. So if I actually tighten it properly to 11.8, I was kind of loose on the bottom. We were at like 11.7. So if we go to 11.8 on the bottom, then we'll be good. Because you can see this outer edge was already hit once in the last attempt, and it's pretty much the same pattern as before. You can see one was slightly lower than the other. So that's good. Now we're covering more in the middle, covering a bit in the bottom. Thermal paste will help out with the rest. It's still a bit of a gap, but if we just make sure they're all 11.8, I think we'll be in business. So we can take that information and prepare for thermal paste, and then just make sure they're all tightened. I will make a note to not bias towards the top next time as well. We have options here. I was considering, this is our care package from Thermal Grizzly. I was considering Conductonaut liquid metal, but it is, the problem with Conductonaut is it's electrically conductive, and I like Conductonaut a lot, and it would be fine to use if I'd basically have to use electrical tape around these all of these little ICs, so like the resistors and the capacitors, to make sure nothing shorts, and it wouldn't be that bad, but we are taking on enough risk as is that I don't need to compound that with an electrically conductive chemical. It would improve performance, but this stuff, which one is this? This is Cryonaut. Cryonaut, coming in an innocuous black tube, and just kind of oozing out on its own even, is still 12.5 watts per meter Kelvin. So I don't really think we need to go with liquid metal. It would get us a bit, but it's really not worth the risk right now. Dang, this is just like spilling out. So for this one, the approach we're taking is manual spread. So I'm just going to cover the whole thing. I'm not even going to clean the excess because it's just not relevant. Okay, so any excess will squish out, and then stuff that's contacting the sides of the mounting or the package assembly will conduct into this cold plate. So we can pick up some extra temperature there because the cold plate is larger than the silicon. So here's what we're going to do now. I'm going to get the thermal paste off my face and my hands. And then this thing's pretty much ready to go. So what I need to do is thermal test, just a really quick one. Just plug the card in, turn the computer on, check the temperature idle. If the temperature idle starts climbing towards 90, then we shut it down and tighten the screws a bit more to improve the contact. If the temperature looks fine, I'll put it under like a 30-second load, and if it climbs towards 90, we'll shut it down and tighten everything. If it doesn't, then we're good to go. Now we don't have HBM sensors, but there's a good chance if the GPU is fine, the HBM's fine. Especially with, I mean, I can physically see down there, and I can see the die is contacting the cold plate. So I think we're good. I'm actually pretty happy with this one. This is a 280 liquid cooler on here, so it's going to be pretty powerful cooler as far as video card cooling goes. I almost forgot this is a Titan V that we're working on, so it is doing 250 plus watts. We're going to try and push it towards 300, and the cooler should be sufficient. I'll probably replace the fans with maglevs or something like that. But yeah, I need to do some cleanup and testing, and I think we're good to go. If you liked this coverage and you liked the mat I was using, I'm very pleased with how it came out. You can pre-order it at store.gamersnexus.net/modmat. We have information there on what it does if you are curious. Otherwise, you can help us out in smaller ways at patreon.com/gamersnexus, or just subscribe and make sure you watch the follow-up content. That's just as much of a help as everything else. Thank you for watching as always. I'll see you all next time.